Marisol, I think we can go ahead and get started with the announcements, and then any stragglers we can post that information in the chat.
Yeah.
So great. Welcome to this session of our learning sessions. We're happy to have you guys on the call this month. Today we'll be hearing from Matt Pevarnik with GE on OEMs. And their role in the industry, the technology, taking a look in on some of their projects. So really excited for this learning session. We want to start out with a couple of announcements from Flow and from the NHA. First, our upcoming calls, April 20th is the April call. We'll have a meet and greet /101 with the Department of Energy and their labs. May 18th is after Waterpower Week, so we'll do a bit of a recap for Flow members. Great opportunity for those who did attend to have a debrief, a couple reminders, opportunity to share what they've learned, some of those hot topics that were discussed, and great opportunity for those unable to attend to glean that information from those who did go. And then we'll probably have a short speaker with that as well. On the topic of Waterpower Week, we have a very exciting negotiation workshop. It's tools of the trade, skill building, and applications for negotiation techniques. That's going to be Wednesday the 10th from 10:15 a.m. to 12:30 p.m. It will consist of an hour training on negotiation. We have a great speaker coming in from Norton Rose Fulbright, Luke Edney, and then it will be followed with an hour panel discussion on different negotiation techniques and how our speakers have used them effectively or ineffectively. We've confirmed Charles Sensiba, Connor Smith, Tim Sullivan, and Luigi Resta. Each of them have different backgrounds in the industry and come from different sides. So very valuable insights there. There is a Flow discount for Waterpower Week. Feel free to message Marcella to get that discount. It's pretty significant, so I definitely used it. But also let us know if you need help in approaching your manager, your leaders, to advocate for yourself to go to this conference. It's very valuable. We'll also have a session connecting university students with young professionals in the industry. That's going to be on Monday, the 8th of May from 7:30 p.m. to 9 p.m. And Nuria Holmes and I will be speaking on a panel for that. And then we'll have a Flow /Young Professionals after party. So great event to get to know everyone in Flow, network, have a great time while we're there at the conference. There is a ticket required for that, but that's going to be Monday the 8th. Okay. And then I think Norbert has some announcements.
Yeah. So we have the National Hydropower Association Midwest Regional Meeting, April 25th and 26th up in Madison, Wisconsin, Middleton, near Madison, Wisconsin. And we are having during day one, after the dam tour and during the asset owner meeting, we're having the Clean Tech Career Showcase, which is going to be over at the campus. And it is from 2 to 4. And there's an open forum for all the college students to come and meet with industry experts and shed light on what they do and the different aspects of the industry. So we're really excited for this, and we have quite a good group of contractors, engineers, regulators, and all more. So it's going to be a fun time. So we're really looking forward to having people show up for that. And please, if you're going to be at that event, spread the word. And next week you should see some stuff coming out. An actual sheet, so you can send that around. So that's the update for National Hydropower Midwest Regional Meeting, end of next month. So, Maricela, you also have some updates?
I do. So the call for speakers for Clean Currents is open. We're now accepting applications. So if you have work that has important implications in conventional hydro, pump storage hydro, small hydro, marine energy. You want to hear from you. If you go to the Clean Currents website, there's a bar at the top that says call for speakers. It'll show you the application process. So we hope to hear from you. We would love to have more flow speakers. If you're working on interesting projects, that's the way to, I guess, get them in front of our committees. So let me know if you have any questions.
Sounds great. Camille, would you like to introduce Matt? I think we have a good group here now. If people trickle in, we can keep going.
Yeah,
So.
should we do a quick intro of new members? Or we'll each just choose a person. So first, picking a name that I don't necessarily recognize, but Ian Johnson. Do you mind giving a brief intro of where you're from, what company you're with, your role in the hydropower industry?
Sure. Ian Johnson. I work for the New York Power Authority. I am a project manager for major projects in northern New York, mostly concerning the Long Sault Dam and the Robert Moses Power Dam. I have a breadth of projects that I could discuss, but that's just my little short intro. I work in the White Plains region and are a frequent flyer to Messina.
Great, thank you, Ian.
No problem.
Great area up there.
It's cold for sure.
A little cold, but yeah. So all right, Janelle Bates. Would you like to give a brief description?
Sure. I've been part of Flow before, but Janelle Bates with the Ontario Waterpower Association. We do a lot of work with the NHA, and I've just kind of been tagging along on the Flow here. I'm Director of Communications and Member Services at the OWA.
Thank you,
for
Janelle.
continuing to support and join us.
So to me, I have two things. One, who is this 980 number?
That's Mark Christian from Eppery.
Yeah, awesome. Thank you. And I have never seen Christy Terrasa on here.
Hi, Christy Terrasa. I work for Sea Power. We're in the wave energy world. So nice to meet you all.
Thanks for joining us. Excited to have you on here.
Well, great. Thank you all for joining us. We have the opportunity to hear from Matt Pevarnik. Matt is a senior sales leader at GE Renewables Hydro Division. Great leader in the industry, and GE is an OEM in hydropower. So he'll be talking a bit more on that. Matt is also on the board of the NHA. So Matt, we'll go ahead and turn the time over to you. And for anyone on the call, feel free to leave your videos on. You can have them off if you're more comfortable with that.
Thank you for that introduction, Camille, and thank you for the opportunity to present to you today on what we OEMs do. And I'm going to focus on runners today, so turbines. And Camille, remind me again, I have until when? The time? Just want to
I'd say, stopping for questions in between, looking at 1:40-ish.
Okay.
We'll stop for questions. Officially, anyone can ask you a question or comment on what you've said, and then we'll look to close out at about 1:55 Mountain Standard Time. Thanks.
Okay, great. As far as questions go, I'll do my best to answer the questions. I might not be able to, especially since if we get into some of the hydraulic design, but I'll get back to you. And then another reason I might not be able to answer a question has to do with trade secrets. So I have to protect GE's interest in that. So anyway, sorry for that in advance. going to share my screen. I am now in presentation mode. You can see, okay. Can you see my screen okay, Kim?
Yes, I can
Matt,
see it. It's showing the presentation mode instead of just the presentation, just so
Right.
so you're aware.
It's in presentation mode, right?
Mhm.
Good.
Yes.
Oh,
it's not in
no,
slide mode, Matt.
I'm
So
seeing yeah, I think I'm seeing presenter's view. And I think
correct.
if you go to the display settings on top, if you see the top, yeah, top panel, just hit the display setting and just swap presenter view to slideshow. Yeah,
Thanks,
there you go.
Kishros.
Great. So again, thank you. I want to talk a little bit about what's going on with GE. You may or may not know that GE has elected to break into 3 different companies. And the first company that was that left the GE family is GE Healthcare, and GE Vernova, GE Power that we're part of, the group that is the power production group, and I'll get into what those groups are here in a second. We and aerospace will be splitting apart. So GE Healthcare is now, it has its own trading stock symbol and its own separate company. And the reason GE did this was they discovered, like a lot of other big conglomerates, is that there's a lot of people that would like to invest in healthcare and don't care about power or aerospace, and vice versa. So starting next year in January of 2024, our brand name will be GE Vernova. And it's a really clever thing that the organization has done here, and I'll explain that. So it's going to be these 12 companies. And of course, Hydro is part of that company as well. But as we go and embark on the energy transition, so as we go from a carbon grid to a carbon-free grid, these companies working together are going to get us there. So in addition to the existing fossil fleet that we still need until we can wane off of the fossil fuels or go to hydrogen fuel for the gas turbines, we're going to need to have an abundance of that. There's going to be a need for nuclear small modular reactors. And by the way, this is a 300 megawatt small modular reactor. So a lot different than the large reactors that we're used to seeing that were built back in the 50s, 60s, and 70s. So that's part of this group. Offshore wind business is really active business for GE, and as well as the onshore and also in repowering all these wind turbines. So after about 10 to 15 years, there's an opportunity to install new and improved blades. And so we have a company that does that we partnered with called LM Wind Power. And so one of the things that GE has also done is found a partner that can help take the old blades and recycle them so we can pulverize them and use them as aggregate and concrete. So anyway, this is all part of the energy transition, and hydro, especially pumped storage hydro, is going to play a significant role in that. GE Hydro has about 25% of the world's hydro equipment. We're in over 180 countries, 52,000 wind turbines installed. And what's really neat is if you ever make it to Schenectady, New York, and have a chance to go inside GE's headquarters where we're monitoring all of these wind turbines. So close to 40,000 are being monitored, and that's through our digital services that we do that. So all the wind turbines are being evaluated. Are there any failures? Are there pending failures? Things like that. And one of the clever things we're trying to do now is take those lessons learned, that knowledge base, and apply it to hydro, because we think hydro can also be operating that way someday soon. Plants collect a lot of data. Some of you are operators, you collect that data, but what do you do with it? How can you analyze that? How can you come up with a good crystal ball to decide when to replace those components? And we have over 70,000 employees worldwide. And I'm happy to say that since January of this year to right now, we've been able to hire 30 new employees in North America, so between Canada and the US. So we're hiring lots of people to support all the work that we have going on. So that's GE. Let's see, I have to go to page down. Okay, you have the new screen, correct? So the next few slides,
Yep.
I want to kind of set the stage for what's happening in the hydro business and us OEMs and how we're having to change, the way we've traditionally designed equipment. So whenever we're replacing equipment nowadays, it's not going to be an in-kind replacement, and we're going to change the equipment to address today's current market and then also the environmental concerns. So whenever you go to get a new FERC license, you're now going to have requirements for improved fish friendliness, improved oxygenated water, less oil. And then whenever it comes to the turbines themselves, they're going to need to be more flexible, have more output, have more efficiency. So all of that is being impacted, one, by environmental regs that we're seeing by the NGOs and the FERC licenses, and then also what's happening in the markets. And I'll show that on the next couple slides. But this is kind of interesting to see where we'll be in the United States from 2021 projections to 2050. We're expecting almost a 20% increase in electricity demand. So that's a significant impact. And then this is a breakdown of the fuels. So when I started in the business many years ago, 70% of our electricity came from coal, and today it's about 23% and projected to be down around 10. Nuclear is at 19%. I don't necessarily share this opinion that it'll be 12%. I think it'll be much greater. I think you'll see much more nuclear plants being built to help displace this natural gas number. And then, of course, the renewables are going to jump big time. And a lot of that is through the solar here. So there'll be a big increase in the solar market. Wind will continue to grow. And then hydro is kind of flatline. But I'm hoping and keep my fingers crossed that that's going to go up with pumped storage. So I have two graphs here, 2 different days in the state of California. And I don't know if anybody ever looks at the CalISO website, but I always like to look at the demand and the supply curve. So this is just from last week, March 9th, and the demand was 28 gigawatts. Pretty simple. Everyone's sleeping, you wake up, here comes the first peak, go through the midday, everyone comes home, it takes off again. And, that's the duck curve. So what's the supply look like? And this is why it's really important to understand this, and this is how it's impacting the hydro business in a big time way, is you have here, this is the gas that's going on right now that's being supplied for the state. And you have about 11 gigawatts of gas, and the solar comes up. And of course, the gas can start to back down, and then the gas comes back up. The blue line here is hydro, large hydro, more than likely pumped storage hydro. When I talk to a lot of the pumped storage users in California, so the PG&E Helms, the LADWP Castaics, they are starting and stopping and cycling their units quite a bit for the integration of this solar. Because as soon as that sun comes up, you have about 4,000 megawatts of wind at night, and then it peaks all the way up to about 14,000. So you have about 10 gigawatts of wind coming on. So from the previous slide, the solar is going to increase substantially. So this curve is going to be even more steeper, which is even going to put more stress on the other technologies to be able to flex. So hence the first thing that we need and that we're being asked to do, and we're seeing in our proposals now, is, hey, GE, hey, Voith, hey, Andritz, and the other suppliers out there, we want a turbine from you that can operate not only from 100%, that used to go down to maybe 70 or 60%, but we want to go to 0%. So we want the whole operating range. And you know what else we want from you? We want to make sure that it can start and stop numerous times a day for the integration of renewables. So this curve here, and it's pretty indicative of going on elsewhere in every other state, of how the renewables are moving hydro around, and hydro is playing a significant role in integrating the renewables. One other neat thing on this slide, and I just started seeing it last year, is this little orange line down here is the batteries. So these are all the batteries in California that are getting charged at night, discharge, and then they're charging up with all the solar at night, and then they're discharging, and then they go back to charging mode. So it's kind of neat to see the batteries on here, and they have a call for a significant amount of batteries to be installed in California as well. So this curve is going to keep getting bigger and bigger for the batteries. And then they have the nuclear plant, Diablo Canyon, 2,000 megawatts, steady as she goes. And keep that in mind, because at the end of the presentation, I have a slide from our nuclear friends from GE. Now, so this is March 9th, 2023. I got to be careful the time. I got a lot to get through, but I want to set the stage for what we're doing. So hottest day in the year in California was September 6th last year, went to 51 gigawatts in demand. And this was the gas that came in, so almost 28 gigawatts of gas that's going to have to be replaced someday. And that's what we're trying to solve. We're all trying to solve that, is how do we take care of that 28 gigawatts of gas and what can be replaced with hydrogen, nuclear, pump storage. But anyway, that's what we're all trying to solve, and try to solve it quickly and not let this continue to go without making tough decisions on, let's start digging holes in the ground for pump storage or nuclear units or hydrogen or something like that. So pretty significant amount of megawatts at 51 gigawatt demand. And then you add 20% on that with all the electric vehicles, electrification of homes, and it's going to be pretty significant and drastic curves. And hydro is going to play a big role in making sure that it can balance the renewables. I'll pause there before I get into now some of the technology. Any questions from anybody?
Looks like we have a question in the chat from Patrick.
Okay. And I can't see that.
Oh yeah. Hi, it's Patrick. I'm with the DOE, and I was just wondering, like, I've heard people suggest that the red curve for imports are also largely made of hydro, but I think it was just like a guess. But I'm wondering, does anyone know? Do you or anyone here know? Is that true?
Good catch. When I was rehearsing, I did pick up on that, but I forgot, Patrick. Those are a ton of imports coming from the Northwest. Absolutely. Bonneville Power is sending down a boatload of hydro. You're absolutely right. Yep. So hydro, not only the blue curve within California, but this is the imports here. And then there's a nuclear plant in Arizona. I think it's called Palo Verde, sending some power in. That's imports, but the majority of that is hydro from the Northwest. So thanks for picking up on that. So when you put these two together, the hydro is pretty significant. That's helping California. Thanks you for that. Any other questions? Great. Okay, so typical hydro plant, and what GE gets interested in and excited about on the hydro side is number 3, which is turbine shutoff valves. Number 4 is your turbine. Number 5 is your generator. So this is a typical hydro plant. And one other thing I'm going to get into here shortly is the head variation. So the higher the head, the lower the head, it's going to be different technologies. So we're worried about the head at this upper lake reservoir, river, stream, and then the lower head. And that's how we design our turbines according to that and the megawatts. But again, whenever we're doing manufacturing, heavy manufacturing, or supplying brand new plants, it'll typically is this equipment, balance of plant, control systems. So we pick up a lot of electrical and mechanical balance of plant, but those are the 3 main mechanical components that I'll be talking about. Well, 4 and 3, but the generator, maybe we could do that some other time. And then GE Grid can provide a lot of these grid components as well. We don't get into penstock design or providing any type of piping like that. We leave that to other people. And also a lot of the hydromechanical work, the gates, the stop logs, that's all supplied by others, but our core expertise lies right here in what we like to call the pit. So turbine generator, that's our expertise there. On the hydro product portfolio curve here, or graph page, what I want to share with you here is the different technologies. So I mentioned just previously about the head. So this is what's found on the x-axis, going from 0 to up to 1,000 meters of head. So the difference in elevations. And then on the y-axis is the megawatts, so 10, 100, and 1,000 megawatts. So for low head and low megawatts, it's bulb units. GE's replacing the 8 bulb units at Rock Island Unit Number 2. We just started that project, so it's right on the Columbia River, Rock Island, Chelan PUD. So we're happy to have that contract. The next up is the Kaplan runner, so getting a little bit bigger head differential and a few more megawatts, getting up to 100 plus megawatts. And you can find the Kaplan runners here. And the Kaplan runners at McNary is a project we have with the Army Corps of Engineers. We're replacing those runners, and it's a large project where those runners will be replaced over the next 14 years. And they're also going to be fish friendly. So stay tuned for the fish friendly talk here in a second. When you get up to the next size, now the head range is getting a little bit bigger, and also the megawatts. And this is the majority of the units that are found in the United States are the Francis units. They're pretty much found in the southeast all the way to the northwest and also up in the northeast area. When you get into the really high head areas, so some of those steep areas in California, you'll find a lot of Pelton units. So again, very high head, and the megawatts typically not more than 100 megawatts. And then you have the pump storage units, which sit up here at the higher heads and the higher megawatts. So that's the portfolio of products that we manufacture. Not too many new units are being designed right now. Conventional hydro in the United States. There's a lot of like non-powered dam, 5 megawatts or less. Others make that GE as bigger equipment size type, but as far as new installations go, it's going to be mostly pump storage, we feel, for us. But as far as replacement goes, we're replacing them with new and improved equipment that we'll be talking about here in a second. So a little bit more details on the turbines themselves. And so there's the impulse turbine, which is your Pelton runner, and then the reaction, you have the Francis bulb and the Kaplan runners. And then this is how the Pelton runner works. You have jets that come in. So from your penstock, the water comes in and the jets spray on those buckets. And that's how you spin the turbine, which turns the generator to make the electricity. And this is an up close and personal look at the Pelton buckets. And this is the nozzle there that's used to go ahead and spray the water onto those nozzles. And this is the reaction turbine. So you have the pressure coming here on the front side and on the back side. So it's a pressure differential, which turns it just like with a wind turbine when wind blows. So the water then hits the Francis turbine, the Kaplan propeller, or the bulb, which goes ahead and turns and rotates the shaft, which turns the generator. So those are the reaction type runners. Looking inside the shop a little bit and also with the site. So one of the things you see here is a propeller unit that's being manufactured. Here's a picture of the Kaplan, and then this is one being put into place and hoisted in. So once we go ahead and manufacture these in the shop, typically you have to take them apart, put them back together when they get to the site, just too big to ship for the larger ones. So whenever we're designing these, we always take into consideration transportation studies. So coming from our shop in Montreal to get to the site in the West Coast, we do transportation studies. Does it make sense to drive a truck across the states, or do we go through the Panama Canal? What makes most sense for the size of the equipment? So that's always done whenever we're bidding jobs, is what does that transportation look like? It's hundreds of thousands of dollars to bring stuff and equipment to the site. By the way, I remember when I was selling wind turbines a few years ago for Alstom that was bought by GE for a 3 megawatt wind turbine. It took 12 truckloads to bring one turbine to the site. So if you can imagine the truck traffic going through town if you have a big wind farm that you're building. So I mentioned earlier about digital. That's one of the divisions that's part of the GE Vernova group. And digital is relying on collecting data, so condition-based. So what is the actual condition of the unit based on all these sensors and all these analytics that I can run? And then the other way to look at it is time-based. So typically, when you're looking at a power plant that I showed you before, where you have the turbines and generators, the generators typically get rewound every 30 years or so, and runners are replaced every 50 years, plus or minus, but you can have things that can last longer or wear out faster. And we think they're, well, you don't think, we know they're wearing out faster because of the way they're being operated and cycled. So for this particular customer, they have 30 units in their fleet, over 1,700 megawatts, and the average age is 57.7 years. This is a few years ago, so it's probably over 60 years. And most of their units here have probably been through their first rewind, except for these two newer units that were installed. A lot of them probably have already had runner replacements, or they're looking at them. And then some of them might be looking at their second set of rewinds. So that's a time-based. Whenever you're looking at it, now that we have collection of data and sensors and monitors, we can go ahead and do a digital base. But so I'll pause there if there's any questions before we get to the next section.
Yeah, Matt, we have one in the chat. Just a couple seconds ago, back on the types of turbines. What is the smallest units you guys have manufactured so far, like in terms of megawatts and kilowatts?
Yeah, well, it's not kilowatts, and we do a lot of small hydro modular equipment outside of the United States. We do in Brazil and Europe, and some of the small modular equipment's 5 megawatts plus or minus, up to about 20 megawatts on the modular side. So in the United States, we're just not set up to be competitive, but we can make the smaller ones, like I said, down to 5. When you get below that, there's a lot of others out there that specialize in that and are much more competitive.
I
Great.
think
We
someone
had a
was
follow-up
also.
to that. Yep. Go ahead, Maricel.
Oh, I was going to say, I think they were asking in terms of pump storage turbines and also reversible turbines.
Oh yeah. Okay. So for pump storage units, we look at everything, above maybe 20 or 30 megawatts, and definitely 50 and above. So, but when you get below the 20 or 30, it just doesn't work out for GE to be competitive. So, but we'll look at everything and just make sure we don't have a reference out there. We've been around for 100 years doing this in pump storage. We have a lot of equipment there. So if there's a reference, then it makes it a lot easier to go ahead and provide smaller ones. But typically we don't play in that area. So design for flexibility. So way back when, 50 years ago, when all these units were being built, it was pretty easy. You started it up and you adjusted it, and you could operate in this nice little green zone here down to from about 100% down to maybe 60%. And going back to that graph of California ISO, the requirement now is I want to operate down here now. OEMs build me a turbine that can not only give me this extended operating range from 0 to 100% megawatts, but also I want to make sure that if there's drought conditions or there's a wide variation in the head, I want you to be able to manage that. And one of the things that we run into as equipment manufacturers, and when we're designing this, is there's a lot of nasty things that happen at the lower loads. So what we have to do is design for that and make sure that we're taking care of some of these items that could really wreck a turbine if you operated there for a long period of time. So that's some of the things that we take into consideration in the flexibility market. And this is what everybody's seeing now, from peaking to low load to spinning reserve to cycling, starts and stops, frequency and regulation. And it's only going to continue to get, I don't know if the word's worse, because we'll sell more turbines, but there's going to be more of this, and it's going to be more challenge for us. But hydro to the rescue. Whenever we're looking at the system, we're always looking at the weakest link, and for operating from 0 to 100%, our engineers will be looking at from the generator and say, okay, when we look at each one of these components, and we'll look at, the fatigue analysis, stress analysis, and what happens whenever it is started and stopped numerous times, and what does that do to the particular components and the connections, and where's that weak link at? So how do we make sure that it can withstand that? And down here on the turbine, all of those components that are looked at very closely for increased cycling, increased starts and stops. So that's what we're seeing, and most of our proposals these days is to be able to handle extended 0 to 100% and higher head ranges. Design for air rating runners. This is really cool what we can do now on the next couple slides from an environmental standpoint. And air rating runners have been around since probably the 1980s or so. But one of the things that happens, especially in the Southeast in the summer, and you have these rivers and they start to run low and the oxygen levels are low. So what we've been able to do, the equipment manufacturers, is design air rating runners. So whenever you get into those hot summer months and the water oxygen levels are really low, which isn't good for aquatic fish life, what we can do is, through natural air admission through the air rating turbines, is allow air to come in through the turbine, through these areas here, and oxygenate the water. So we've done a recent one in the Southeast, and we're able to increase the oxygen levels substantially just with one of the 3 units. So it's a very successful air rating turbine design that we have, and it's very efficient at emitting this air in. Existing systems back in the 80s relied on compressors. So again, it's a parasitic power. You have to maintain that compressor, but now through the air rating turbine designs, we're able to put in natural air. So for those 3 or 4 harsh summer months, whenever the oxygen levels are really low, we're able to put oxygen in the water. Design for fish friendly. We want to make sure that our turbines are being very friendly to the fish. Currently, the bulb units, you might remember those are greater than 90% survival rates. The vertical caplins are greater than 88%, and the Francis units, not so lucky there, fish. It's less than 80%. But one of the things we're doing right now on the project with the U.S. Army Corps of Engineers on the Kaplan units there is we're getting this number into the high 90s, which is good news for the fish and good news for us as equipment manufacturers and the Army Corps as owners to take the time to design that turbine to be able to, make sure the fish are surviving when they go through there. And this is some of the cool things that we're doing right now as we're studying it with the government and, making sure that, a couple of things, whenever the fish come through the turbine, there's no sharp edges where they could get cut or pinch areas, make sure that the pressure zones are minimal. One of the things that happens with the fish is they can sometimes get disoriented when they come out the other side. They're floating on the water, and the eagles are happy because they're easy to catch then, but it's not good for the fish. So anyway, so we're looking at everything in there and studying it and, working on, those studies and making sure that we have a really good Kaplan design for that customer at the end of the day. So I'm going to stop there on some of the designs before I get into some GE manufacturing. And I realized I'm right at the 40 minutes past the hour. So if there's no questions and I have probably about 5 more slides to get through. Camille,
yeah, Matt, I have a question.
Yeah, go ahead.
Let's go with, if I pronounce this wrong, I apologize. Vishwas, you have a question?
Yes, I was just wondering, and I was curious, Matt. Great presentation, first of all. But for the fish friendly turbine, I've realized that it really depends on what type of fish species it is and things like that. So are the plans then to design some of this based on the location or the site where a turbine is going to get installed, or how does GE plan to tackle that?
Yeah, absolutely. Up in the Northwest, it's salmon. When you get into the East, there's a ill. So yeah, you have to make sure that you're studying the right species that's going through there. And so that's all done with the experts in the labs like at PNNL and others that, bring those biologists or whatever that discipline is to the table to let us know. Absolutely.
Looks like we have another question with Mark Christian.
Howdy. So I know we're short on time and you're moving into the manufacturing side, but if you could please include any information you have on supply chain extensions or timelines.
Yeah, sure.
With specific items and if that's impacted forced outage durations. Thank you very much.
Okay, very good. So
then
let me get into, yep, go ahead.
So I think feel free to go up till 150 or past that. We'll adjust.
Okay. Okay. All right. Very good. So let's get into a little bit about GE manufacturing, GE hydro manufacturing. So we're in, of course, North America. This is where our headquarters are back in Montreal, and we have a large manufacturing shop. I'll walk you through that in the next couple slides in Sorel Tracy. So just north of Montreal by about an hour or so. I'm in Denver at our U.S. hydro operations, and we have probably close to 90 people that are here in the United States. Right now, we have 20 active projects going on, about 9 gigawatts worth of hydro work, whether it's turbines, generators, or turbines and generators that we're working on right now in the United States. And those projects are in various stages of initial design, like we're doing with Chief Joseph Dam. We were just awarded all of the generator rewinds there. So we're doing the design phase right now. We'll be going to manufacturing shortly. And then some other units that are in complete manufacturing design and others are in complete overhaul and commissioning. So we run the gambit in terms of those 20 projects. So that's North America, large manufacturing facility in Latin America, India, China. These are all being challenged now as a result of the IRA. So we are right now looking to pivot and go to existing GE shops in the United States. So GE gas turbine, GE steam turbine, they have a lot of manufacturing capabilities. And then a lot of our strategic suppliers are helping us. As far as supply chains go and COVID, it's getting better. We're still having issues with delays and equipment getting out. We have issues with quality, as probably like with your company, trying to find, those people and keep those people has been a challenge during COVID. That's why I announced we hired 30 people, which is just great news in the first 3 months of the year. That's great news for us. And then we're starting to see our suppliers and things settle down now. So we hope to see improvements. The inflation hasn't helped the industry at all. The inflation has caused increases in prices, from 10 to 20 to 30%, and that's very unfortunate. Those have settled out. They haven't come down yet. But anyway, that's what we're managing from the supply chains that we have and that what we're seeing from our suppliers. So one of the things that happens if it's a brand new project, say, especially with a pump storage project, we have to do model testing. So what we want to do is make sure that whenever we design this turbine, a pump turbine, or some of the others that we are designing right now, whether it's that Kaplan or those bulb units, that we do model testing. So in our shop in Grenoble, France, is where we have 7 test stands, and we create a scale model, 1/30th of the actual size, and we test it in one of these test stands. And we run through a series of tests to simulate actual operation to ensure that what we've designed is going to meet the customer's requirements of that extended operating range and the head and the efficiencies and the performance and the cavitation and the rough zones and all of that. And that's what we do in this lab so that we can go ahead and make sure that we make our guarantees. And here's a picture of one of the models right here. And then this is, of course, the final product after we've completed the model testing. You typically bid for maybe 2 model tests, and you hate to go more than that because it takes time, about 3 months to model, and you really want to nail it on the first one if you're lucky. Customers come over, they witness the model testing, you put it through its hoops and make sure that you nailed it with the design engineers. Otherwise, you go back to the drawing board, you make tweaks to the blade profiles, and then you try it again. So that's the model testing. So from notice to proceed till the completion of the model testing is about a year in duration. And then once we get comfortable with, at some point, we can start procuring castings and whatnot for the shafts and the other large components, because we feel pretty comfortable that, if you order this shaft, it won't have to be, milled down too much. And then once we're done with the model testing, then it's full steam ahead with the final design, releasing drawings for manufacturing, releasing them to suppliers. So again, from the notice to proceed to the completion of the model testing is about 12 months. Then we go into heavy duty engineering, manufacturing, and then about the 24-month mark after NTP, equipment starts showing up at site. This is our shop in Sorel Tracy. A little bit of history. Back during the war, they were making propellers for ships, and Hydro-Quebec asked if we could convert it to making turbines. So we went ahead and converted the shop. And so this is inside the shop where we do the manufacturing of runners. We have years and years of experience in this shop. I'm going to go through some quick slides here so we can get done here in a few minutes. I mentioned about turbine inlet valves. This is another large component that's starting to see a lot of stress from all the starts and stops. So at the bottom of the penstock is this large valve, and this valve gets open and closed a lot. It's been in there for 50 years, and it needs to be replaced. So this is one of the valves that we're making for one of our customers. So it's huge, it's large, it takes a lot of machining, heavy equipment to move it around. And then you even have to worry about workers, and their safety. So here's a lanyard, and he's tied off in case there's, an accidental slip. So that's a turbine shutoff valve. Here's a Francis runner and a pump turbine. So just to give you an idea of what the welders go through, and these guys are fantastic, what they have to go through. Here they are laying inside of here doing this welding. This particular welder had to go inside this pump turbine here and do the welding there. So really tough job these guys have to do. Here's a Francis runner that's being built. Again, our welders just doing yeoman's work, welding these things up, tough positions. This is all blanketed because we're doing welding that requires heat treating. So this welder's leaning over for, days on day doing those kind of welds. And then we have to, turn it on its side to do additional welding testing. And then this is the runner, and it's completed and ready to be packaged up and shipped to the site by these fine people that work in our shop. So that's the manufacturing. Quick thing on pump storage. I don't want to take too much time, but we're building pump storage everywhere, but in the United States, new pump storage. We're doing replacements like at Cabin Creek, and customers are, asking for improved operations as they replace their pump storage units. But we have a lot of work going on in the United States, and in China. It's just incredible what they're doing in terms of pump storage and the gigawatts that will be built. And I said I teed up the nuclear slide. So real quick, I got this from my colleague that works up in Boulder from his presentation. And those small modular reactors, they're 300 megawatts, really cool. And they take up 2.3 square miles for 6 million homes to be powered. If you wanted to do that with solar, it would take up 231 square miles, and wind would be 386 square miles. So just to give you an idea of the size and the footprint, hydro's, probably right in this neighborhood as well for pump storage, probably about the same. And then this I thought was kind of interesting. There's 102 or 104 nuclear units, and they keep all of their waste fuel at their facility. And right now it would fill a football field about 24 feet high if you put it all together. So kind of interesting to see that you hear nuclear waste, but it's just about that much. So anyway, that was my quick slide on the nuclear. That's all part of the GE Vernova group. And again, I think there'll be an opportunity for nuclear. And the reason I like that is you have a 300 megawatt nuclear plant that can't cycle, so you got to pair a pump storage with it. So I think there's going to be another need for pump storage is if nuclear comes back, we're going to have to pair it with pump storage. So there's an opportunity for us hydro folks there. So, and there you go. So I can take any questions if we have any time left. And sorry for running a little bit over.
No
Matt, that
worries.
was great. Do not apologize. Thank you. Go ahead, Mary.
Yeah. There's a question from Christy Terrasa in the chat. Christy, do you want to ask your question or should I read it?
Oh, sure. I can go ahead and ask it. Just wondering if you have any recommendations for how small businesses can best work with or co-develop components with larger companies like GE.
Absolutely. Karen Vela, she's our small business liaison, and I can get her email address and put it in the chat and reach out to Karen. And we're always looking, like I said during the presentation, we have to pivot from the international supply chain to the US, and we're looking for US suppliers. So absolutely. It'd be great to get your contact, and you can talk to Karen and about your products and services and see if we somehow can't start doing business with you. Thank you.
Thanks.
Any other questions?
We do have a few other ones that right before that, and it was about the cost for the fish-friendly turbines and you know, just the basics of that's more expensive. And then I believe there's a follow-up with that asking if they're being used right now, and it's just following up a little bit more specific on those fish-friendly turbines. That was the question, kind of.
Yeah, sure.
What's the cost associated with normal?
Yeah, so the cost right now is all part of the design. You know, as we're spending time in the lab and doing the studies and doing the model testing, and that's where there's a lot of initial designs with the prototype. So that's what is spending a lot of time now. As far as the difference between a regular non-fish friendly versus a fish friendly runner, I wouldn't think there would be that much of a cost difference. You're not going to change the profiles that drastically, so I think they'd be pretty comparable.
Great.
Okay.
Mike,
Any other questions?
All right, Mike, did you have any other questions relating to that? Did that answer your question?
Yeah, it did. Thank you.
The one question about the cost of the air rating runners, they're yeah, probably 20 to 40% more because of the air rating design and what you have to do with that. So is that the one question there? Is there another one?
I have a question linked to that. Oh, go ahead.
The question about physical models compared to CFD models. If we have something that's very close in design, not too far off from the head of an existing unit, then we feel very comfortable making guarantees with CFD models. So, and actually we do a CFD model, and we will or will not do a physical model.
Hey, Matt, I have a quick question for you. You talked about a lot of exciting and trending things, and GE is certainly one of those companies that is on the forefront. What is it that you're most excited about with what GE is working on right now?
Well, I think what I get pretty excited about is the fact that, you know, we in the hydro industry can play such a significant role in this energy transition. And with the other technologies that GE and Vernova are all going to be working with, I see a lot more collaboration that we'll be doing with our partners now on, you know, from the gas group or the nuclear group or whatnot, similar type customers, and bringing a GE solution there. But I'm had the opportunity to work in all of that industry. I started off as a boiler engineer working in Western Pennsylvania, crawling through boilers. And so I know the coal-fired, the gas-fired, the oil, the nuclear, the wind, the solar thermal, and hydro. I really love hydro. I've been purely hydro since 2015, and I think we can solve a lot of the problems in the energy transition. And I think that when we start looking in GE Vernova, it's going to force us to, you know, collaborate more as a company to bring those solutions for that energy transition.
Yeah, another question, Matt. Elliot Jackson, what's your question?
Okay.
Hey there. So my work in graduate school had to do with variable speed hydropower. And one of the things that I looked at a lot was how to basically control the speed of your turbine runner to match the efficiency of the runner with, you know, varying flows and heads and things like that. And one of the things that I found was that it was really difficult to find. First off, it was difficult to find the hill curves that someone would give me free of charge, but that was tough. But one of the things that I found once I did get my hands on some was that so many runners are they're developed to be most efficient at synchronous speed because obviously we tend to run the hydropower industry at synchronous speed. And so my question is, with regard to turbine efficiency, I know that they're hyper efficient in today's day and age. Is there still much R&D going into how to make them even more efficient, or is it kind of squeezing blood from a stone at this point, where it's like, listen, we could get you another 0.25% of efficiency, but it's going to cost you X amount more, and you're only going to net this much more energy capture. What's kind of the status there?
So we're always looking to have the best, highest efficiency of the manufacturer. So it's something that we're always looking at. But you're right. We might have squeezed as much as we can out of that, but that's not to say we're not trying to get that extra little 0.25% or whatever it is that, you know, we can make sure that we have a good solution for our clients. So that efficiency is, you know, when it's being built for 50 years, because Elliot, what we're being asked for now is this. We're seeing design specs come from our clients for pump storage for, we want 6 to 10 starts and stops a day. We want a 50-year design life. We want this operating range. And the projects we just commissioned in Israel, we can go from 0 to full load of 150 megawatts in less than 70 seconds. That's fast. That's really fast. Yeah. The variable speed units that we built in Switzerland their reactive power is faster than batteries. It's just incredible. So we're really, really proud of the variable speed technology that's out there and what we can do to balance the grid.
Great. And then if I could just take another 20 seconds real quick, the aerated units, is there an efficiency difference compared to a traditional unit?
Yeah, it sucks when you turn the air on.
Yeah.
But you're aerating the water. So, you know, what you want. You know, each one of these technologies, there's pros and cons. You can't get it all. But, you know, the important thing is the water downstream has oxygen in it. The fishermen are happy and everyone's having a nice dinner that night. So.
Yep. Great. Awesome. Well, thank you so much, Matt.
You bet. Good questions.
Matt, if I could just jump in on Elliot's last question there. This is Megan Bringolf with Eagle Creek Renewable Energy, and we actually have one of your aerating units.
Yes.
We own the High Rock unit.
Yep.
So, to Elliot's question, yes, we do lose a little bit of efficiency on that unit, but our license requires that we meet minimum DO requirements. So without these aerating units, we're not generating because we're not meeting license requirements. So yes, we may lose a little bit of that efficiency, but we still have our units on, which is a win at the end of the day. So
that's great. Thanks, Megan, so much. Appreciate that.
Yeah.
Thank you.
I think we have a question in the chat from Bedamariam.
How is your factory in China? Do they manufacture per Chinese standards? Yes, so our shop in China, it's in Tianjin, and it whenever we manufacture, we have to manufacture them for the U.S. if we're manufacturing to the standards that are in the specification. So it'll be to ASME standards, IEEE standards, and then make sure that that's all compliant. So that's how we handle that in our shops in China. So.
And then do you know,
The bulb turbine, a kind of fish friendly. Well, that's a question I'll get back to you, because we're doing the bulb turbines for Chelan and replacing those at Rock Island. And I have not had discussions with them on the fish friendly side of it. So I'll have to maybe provide that answer for you for your next meeting. But let me take that as a takeaway. So.
Great, thank you. Thank you, Matt. This has been a fantastic presentation. Everyone's had great questions. I know that I've learned so much. So thank you for taking the time to come and speak to all of us. And then Maricela, do you want to close us out?
I just want to thank everyone for being here and for being patient and for asking great questions and for paying attention. I think this has been a great call. I want to respect your time and let everyone go. So Matt, thank you for being here. You shared so much great information. Everyone else, we will see you next month.
Well, thank you for the opportunity to speak with you. I wish you all the best in your hydro careers, and I think we're in a great industry. So great to see great folks like you all, and we'll be solving tomorrow's problems that we saw in those couple graphs there. So have a good rest of the day.
Thanks,
you.
Matt.
Bye.
Bye.
Thanks, Matt.